Our objectives for today's lesson is to look at percent composition. Percent composition represents the relative amounts of each element in a compound, and you'll also be able to calculate the percent composition of a compound using either experimental mass data or by looking at the chemical formula. Percent composition, or as sometimes it is called percent by mass, tells us the relative amounts of the elements in a compound. Our formula to calculate the percent by mass is equal to the total mass of just the element divided by the total mass of your compound times 100. Let's look at a couple of different types of problems. The first one we're going to look at is calculating the percent composition from mass data. So our first question says, what is the percent composition of oxygen and magnesium in the following compound? And so the data that they have given us, they told us the mass of the compound is 13.60 grams. The mass of just the oxygen is 5.40 grams, but they have not given us the mass of magnesium. Based on the law of conservation of mass, all of the mass that makes up the compound has to come from its elements. So since the mass of the oxygen is 5.40 grams, we can subtract that from the total mass of the compound to calculate the mass of the magnesium as 8.20 grams. Now that we have all of the pieces of data that we need, we can start plugging into our formulas. So to find the percent composition of oxygen, I'm going to take just the mass of oxygen divided by the mass of the compound and then multiply that by 100. So our mass of oxygen was 5.40 grams. The mass of my compound was 13.60 grams, and I'm going to multiply that by 100. When I do that, I get a percentage of 39.7%. Most of the time we'll go to just one decimal place on our percentages. Now let's do the same thing for the percent of magnesium. To calculate the percent of magnesium, I'm going to take the mass of magnesium divided by the mass of the compound and then multiply that by 100. So our mass of our magnesium was 8.20 grams. The mass of our compound again was 13.60 grams and multiply by 100. So when we do that, we should get a percentage of 60.3%. And what you should notice is that our two percentages add up to 100%. That should be the case in all of these types of problems. If it doesn't add up to exactly 100, it should add up to something very, very close. Pause the video and practice example number 2. Example number 2 answers. We have 72.2% magnesium and 27.8% nitrogen. On the next slide, I will show you the work on how to do that if you made a mistake. So here we have a compound that is formed when 9.03 grams of magnesium combines completely with 3.48 grams of nitrogen. What is the percent composition of this compound? Okay, so in this case, they've given us the mass of each of our elements, but have not given us the total mass of the compound. So in order to calculate the total mass of the compound, I'm just going to add the 9.03 grams of magnesium to the 3.48 grams of nitrogen. So if we want to calculate our percent composition, we would start with magnesium. The percent of magnesium would just be the mass of magnesium divided by that total mass of compound we just calculated. So we would get 9.03 grams divided by 12.51 grams times 100, which comes out to be the 72.0%. If we want to do the same thing for nitrogen, we take the mass of nitrogen divided by the mass of the compound. Our mass of nitrogen was 3.48 grams. Our mass of the compound, 12.51. Again, multiplying by 100 to get a percent, we end up with 27.8%. And again, we get very, very close to that 100%. The next type of question we're going to look at is how to calculate the percent composition just given a chemical formula. So our first example, we're going to calculate the percent composition of propane, which is C3H8. Now to start off with this, since they did not give us any mass data, we have to come up with some mass data. And the way that we're going to do that is by calculating the molar mass of this compound, just like we learned in one of the earlier lessons. So here we have our compound C3H8. First thing I'm going to do is I'm going to break that down into the two elements that make it up. So we have carbon and we have hydrogen. Then we look at the number of each atom that we have. So for carbon, we have 3 atoms of carbon, and his atomic mass, he was one of our whole numbers, is 12 grams per mole. So 3 times 12 gives me 36. Again, looking back to our formula, we see that we have 8 hydrogen atoms. He was another one of our whole numbers. His atomic mass was 1, so 8 times 1 is 8. And then we just add it together to get our total compound, our total mass of the compound of 44 grams per mole. So now to calculate the percents, we're going to do it just like we did in the earlier examples. So to find the percent of carbon, I'm going to take the mass of just the carbon divided by the total mass of that compound, the C3H8. So the mass of just my carbon was 36. The total mass of the compound was 44. Again, multiplying by 100 to get the percent gives me 81.8% for carbon. We'll do the same thing for hydrogen. The mass of the hydrogen divided by the total mass of the compound. Just the hydrogen was 8. The total mass of the compound was 44. Again, multiplying by 100. And so you get 18.2% for your hydrogen. Again, pause the video to practice example 2. The answers to example 2, we would get 41.7% magnesium, 54.9% for oxygen, and 3.4% hydrogen. Let's take a look at how we got those answers. So the first thing that we should do is find the molar mass for our compound, our MgOH2. So again, taking a look at each individual element, we had 1 atom of magnesium. His atomic mass was 24.31 from the periodic table. We had 2 oxygens. He was one of our whole numbers at 16, so 2 times 16 gives us 32. And hydrogen, we also have 2 of those. His atomic mass is 1, so 2 times 1 is 2. We add it all together, we get 58.31 grams per mole. Once you have all of your individual masses and the total mass of your compound, you just need to plug into our formula. So for the percent of magnesium, we would take the 24.31 grams, which was the mass of just the magnesium, divided by the 58.31 grams, which is the mass of the compound, and times 100. And so you can see the rest of those there for the hydrogen and the oxygen.